Hello and welcome to our presentation on our warehouse inventory management system. My name is Dimitri Lavin.
And I'm Taylor King.
So, diving into our project very quickly, essentially it's just a warehouse inventory tracking system that allows people in the warehouse to be able to track any sort of inventory, any products that are in there, make any sort of reports on those products, keep track of any sort of events that are occurring within that system, and also keep track of orders and users within the system itself. And so the whole goal behind this is to just facilitate any sort of inventory management and tracking for a single warehouse. So we did have some considerations regarding our design. Our initial proposal was a lot more hefty than what it should have been, so we were suggested to dumb things down a little bit by the TA. So the first thing that we did was dumb down the authentication within our system. So instead of having a whole authentication process with logging in and such, we just kept it to just having a database that kept track of all the different users within the system. So that would just be um, adding and removing people within the system, as well as any sort of implementations of certain users being able to do certain things if they're in the database or not. Another thing that we did was remove the accounting system to be able to take any sort of orders or track orders within the microservices architecture that we chose. And then lastly, any sort of databases with microservices were isolated for any future additions, just in case there were services that needed to share the same databases. Now, getting into the first architecture, this is the one that we actually chose for um, our warehouse inventory management system, and this is the layered approach. And it basically just breaks it down into very clear roles. It isolates the business logic layer from the presentation, but also from the database as well. And it's very easy to maintain and monitor. So going into the presentation layer, it's very user-friendly, very straightforward. It does make in-process procedure calls to the logic layer interface, which does communicate with the business logic, and it does allow for user input and control. Now for the class, for the presentation layer class, we do have an app.py file that does contain the PySide 6 desktop GUI. And this just allows the user to be able to interact with the management system much more effectively. Now, with the logic layer does communicate with the presentation layer through an interface. And the logic layer itself, what it does is it just handles any sort of user inputs for the inventory regarding any stock levels. It'll let you know if there's no stock, low stock, or if something's overstocked. Any sort of orders regarding some of those inventory items will be managed and tracked. It'll notify you of any other sort of business regarding these inventory items or user roles, and it does connect to the database via repositories. Now, the class that does manage this is the main.py file, and it is basically just a fast API app that does control all this logic layer implementation. Now, getting into the data layer itself, these are just the databases that keep track of everything that we have going on in the business layer, and everything that is incorporated into the data layer will just be either created or removed. So any sort of inventory items that are added can also be removed, and same with users as well. And this is implemented through a data app class that implements the database manager as well.
Okay, for our second architecture option, we have microservices. The idea behind this was taking a similar approach to the layered option that we had previously mentioned, but breaking apart all of these significant features into their own respective services, giving them a single responsibility. For a lot of these services, we use a RESTful Flask API that's just boilerplate, so we can spin up services very quickly and easily in giving a uniform interface across all the services. The presentation service is the end user's interface. They get to have a nice UI to look at, and it sends off its requests to the orchestrator. And our presentation service is captured in a Flask app in presentation underscore service slash app.py. The orchestrator service, it acts as a gateway to the system level services. All of this is just so if we ever want to add load balancing or any other type of controls, like authentication, we can do that here rather than having to do it at the individual systems. It can be held however we want for more control. And for the service class, we have an orchestrator class. And then for the system services, this is where each of the features from the previous logic layer was broken up and is given their own service where they can query their own individual databases with their respective services. And you can see in this diagram below, we have 5 examples of individual features being broken out into their own service. And now each of the service classes is broken up and each one has its own Flask app corresponding to it. As noted previously, we do not have the accounting service as part of this due to some concerns about the scope of our project. And then for the data services, these are Flask apps presenting a RESTful API for a database to be interacted with. This was done so that if any other services ever needed to be added, they can directly interface with the raw data rather than the structured data that comes from the system level services. And for the data service classes, once again, they're just wrappers around Flask apps that pass queries through. Okay, and then for the layered comparison, this is just contrasting it to the microservice architecture. The layered approach is very simple, has all the business logic in a single application that's easy to debug, and because it has fewer moving parts, it's easier to maintain and monitor. It also requires less infrastructure. There's not as much overhead regarding all of the Flask apps that need to be started to present all the APIs needed for the microservice. Microservices, like I said, offer less overhead for a distributed system by only having what you need on your local machine. This is a trade-off, but if you need everything all locally, then we wouldn't need this necessarily. It also allows for less service interruption because each service is able to be swapped out for something that does the same job, either that's a new version or a different variation of that same service. And you can interact with all these services by just interacting with their endpoints. So there's no need to make new classes or new interface classes. You can just directly interface with the service you care about. And so for us, our selection, we thought about our project as a single warehouse with a limited number of users, and our features are going to be pretty static. So we don't need all the benefits and flexibility that come with the microservice architecture. So we prefer the layered architecture approach for those reasons.
And getting into some of the analysis regarding any risk between these two architectures, because the layered architecture does all run in a single process, it is prone to single point of failure. So it is important to constantly monitor the layered architecture so that way you avoid any system-wide outages. Additionally, because the databases are all layered into the architecture as well and not separate like microservices, it's important that you do monitor the database, or else nothing else in the business and logic layer or the presentation layer will be able to function the way it should be. Regarding the microservices architecture, it is very dependent on services. So you need to import any sort of needed modules for each service. And so it does make startup kind of complex with all the operational overhead. Any sort of network latencies can slow down the microservices architecture as well, and it can just slow down the overall program itself. And lastly, because all the databases are separate, belonging to each different service, it is important to keep any sort of data that is connected to each other very consistent, or else you will have problems within the business logic layer. And just to go over very quickly why we chose the layered over the microservices, just with a little bit of data itself. Um, So we ran some tests regarding on some get methods regarding the two different architectures, and we were able to test how fast each one of them was able to do these. And so the mean response time between the layered and the microservice architecture was pretty vast. The layered architecture did it 4 times as fast, and the total time, it was a little bit more than 3 times as fast. Regarding the variance of the times, it was 10 times better. Any P99 latency, the layered obviously won. And then they were both able to succeed, but because of the speed that we care so much for in this situation, we do give it to the layered architecture. And so it is important to think about the operational overhead of these two architectures. So there is a much more complex orchestration between the microservices and the layered, especially in favor of microservices. And the layered is much more simple because it is a single process. Now, regarding data management, we do have a schema evolution with the layered, and it's important to keep that in mind as well with microservices because you should have some sort of consistency across all the different databases across the different services. And over here, we do have a small picture of what we were able to pull out of the terminal regarding the little test that we did. Now, we'll get into our demonstration. First, we'll demonstrate the selected architecture, which is the layered one. So this is our dashboard, and this just goes to show everything that we do have in the inventory right now and how many different kinds of products. This goes to show if a certain product is low in stock. This will give us notifications based off of different things that we do perform within this management system. And over here, we do get the same notifications as well. So just a quick demo. If we wanted to add a new product, we can add a new product. Let's say we wanted to add mild sauce instead of hot sauce for people who don't like spicy food. So we'll keep that in our system. We'll just make that like 25 cents. So here we can see it's been added to our database. Now, that's just for the product itself. Now, if we actually want to add some of that into our inventory, like if we did get a shipment of that in, we'd have to add the correct SKU, the correct amount of that item. We'll say there's 1,000 of those units. Say new food item performed by me. It's good to refresh just to see the change. And here we can see mild sauce has been added. And we do have the 1,000 units of that. Now, we do have users, right? So currently I'm the only user in here, but let's say if we wanted to add Taylor in here. So we can just give him a random ID. Make up some username for him and email. We'll just say he's a warehouse employee. Now we can see he's been added into the database. Now let's say Taylor was goofing off at work and we need to get rid of him, right? We need to fire him. So we can delete him from the database as well. So if we click on Taylor's name, hit delete user, just letting us know that cannot be undone, hit yes, and then we can see he has been successfully deleted from the database itself. Now, let's say we were trying to take an order for that most recent inventory item that we added. Let's create an order. We know that it was SKU 222. Let's say we wanted to get 500 of these things for Del Taco, because I guess Del Taco likes mild sauce. We'll hit OK, successfully created, and we can see that here we have an order in place. Now, this is just a draft because no one's approved of it yet. So if we click here, click on the order itself, update the status to approved, then we know someone's looked at it. Now, if it's all been taken care of at this point and it's been fulfilled and paid for, click on it again, update the status to fulfilled, and there we go. Now we should see some changes regarding the amount of money that's been involved. Previously, it was like 700 something dollars. Now we can see that it's gone up to 855. Now, lastly, we'll look at reports. Um, Previously, we did only have three products in the food category, let's say, but because we added one more, we do have a fourth. And when you combine all the units of the different food items, we do have 1,015, and everything that's left over is $855. So that concludes the layered architecture And then if we dive into the microservices, we find a very similar um, implementation, just looks a little bit different. Here in our dashboard, it just shows the different number of products we have, the value based on all the units of that product, and then any sort of stock alerts. Here, we'll get any sort of notifications, whether we're adding new inventory items, adding new users, and whatnot. So, if we go into products, products will basically be updated based off of new things that we get in our inventory. So, let's say if we wanted to add this new thing, and also this here, because I'm already a user in the database, this will use my username to check if I'm already an employee of the warehouse, because if not, then it will not let me add to the inventory itself. So mild sauce, category, food, we'll give this the same unit price. Vendor, Taco Bell, and we'll give this a quantity of 1,000 as well. So here you can see the inventory has been updated. We have 1,000 units of mild sauce. We can go to products and we can see that mild sauce has been added and it's been able to pull that from the inventory database, food category, as well as the individual price of one unit. Now, if we go to reports, we can get a breakdown like the reports in the layered architecture solution that we have. We only have one category so far and it's just food, but now we have three instead of two products. We have 1,200 units on hand, which give a total of $1,150 total in our inventory. Now, if we were to go to our users, currently I am the only user, but let's say we want to add Taylor again, give him some random user ID. We'll just make him a warehouse employee, create the user, and then we see that Taylor's in here. Now, let's say he was messing around again, he gets fired from this other warehouse. Delete Taylor from the database, and voila, he's gone. And here we can see the notifications um, that Taylor was added at one point and that we also added a mild sauce to the inventory. But yes, that concludes everything from our presentation. So thank you for watching.